Finally, this is the last topic. We will discuss topic models and clustering, which is a related concept. We're not going to do topic models and software in this class, but because clustering sort of has the issues in topic models and it's easier to discuss. So we pointed out that everything is a bag. Everything is a vector space and everything is a bag. A bag is basically a subspace of my vector space. And so we have documents as points in a space, and we have regions or bags in that space, which are related items. And we have various algorithms, namely we have clustering, we have Gaussian mixture models, which are sort of fuzzy clustering. We have k-nearest neighbors, which will take one point and find other points near it. Clustering takes the world and divides it up into groups. Support vector machines is another way of chopping a space up into parts. We can also do something a little more subtle, which is not directly using the vectors, but by assuming that there are topics and that documents discuss topics. Topics can be defined in a totally abstract fashion as effectively a dynamic small bag of words. So you try to find topics defined by these bags, and then there are various methods, latent semantic index, latent Dirichlet allocation, which find the so-called latent factors. These are the hidden factors, which are not obvious at a first glance. Words or terms are not topics because they're blatant. If the the phrase Michael Jordan occurs in a document 100 times, you can be pretty certain there's a document on basketball. So that's a very blatant topic discoverable by words. Topics, you can have documents which are on topics which never mention on basketball, which never mention Michael Jordan, but you can still have a topic called, say, a topic which is basketball players, and you can have a whole set of things in the basketball player department, and you can match to the basketball player topic in multiple different ways. And if you have 10 top basketball players in your article, probably it's an article about basketball. So that's sort of what's going on there. Topic models are illustrated by Google News, which is a good example of it's a hub because it points to lots of other places, and it groups topics by things like presidential election or Barack Obama or Indiana University or cricket or something like that. And there's these things like LSI or LDA, latent Dirichlet allocation. They are algorithms which find the best set of topics and the best set of words in the topics based on starting with actually the same thing we always start with, a collection, a corpus of documents where each of the documents represented by its words or tokens. An example of how this, why this is interesting comes from applying a topic model, which is using some of the older technology, latent semantic indexing. And if you query for Texas Reagan after a topic model has been applied, then one of the documents it finds does not even have Reagan in it. And that's because these documents were all matched together from the topic model, and then Texas and Reagan, or the STEM version thereof, were in this topic. And so when you queried for Texas and Reagan, you got results here which were non-trivial. We had a similar example with when we queried engine in Bing, and we got the Google search engine back again as one of the returned items. Here, this is the final slide of this deck, which just is an example that John Choi did in my research group as part of his thesis. He looked at the AP News data set. He divided it into 30 topics, and with an algorithm which is not important here, and just tells you the top 10 popular words for 30 and how they appear in topics. And so you can see that here's a topic, something with the stock market. And here's one which has something to do with Russia and governance and things like that. Here's something to do with presidential elections. And you don't start off by feeding in these topics, they just come out automatically from decomposing the documents into a set of topics. So these are important data analytics algorithms, LDA and PLSI and PLSA and things like that are, it is PLSI, not PLSA, it's probabilistic latent semantic, well, it can be indexing or analysis, I guess. So what counts is LS, latent semantic. So these are important analytics, which in a more advanced course, it will be good to understand these algorithms. Thank you very much. And we'll go on to more, a different value of X next time. Thank you.